Hi YouTube. In this video we're going to carefully talk about the differences between pointwise convergence and uniform convergence. So for a positive integer n, consider a function, say f sub n from the domain which maybe we'll call E, and let's make the codomain the set of real numbers for simplicity. So we're basically defining a sequence of functions. So we have a sequence of functions. We have a sequence of functions. Say f1, f2, f sub 3, and so on. And just to add something a little more concrete to this discussion, so as an example, we could define the sequence f sub n of x equal to x to the n, and we can define this on the set 0, 1. So this set here, this would be our E in the above definition. So for each positive integer, we have a function defined on some set. Okay, now let's talk about pointwise convergence. We'll say that f sub n converges to f pointwise. So we're carefully going to write down what this means and then talk about what it means intuitively. If for every epsilon greater than 0 and for every x in our set E, we can find some positive integer n such that for all little n bigger than capital N, the difference between f sub n of x and f of x is less than epsilon. So this is the definition of what it means for a function, for a sequence of functions to converge pointwise to another function, right? You'll notice that in this definition, n here could depend on x and on epsilon, right? Because it could depend on both. So sure, the sequence converges to f of x, but depending on x, how fast it converges, the rate of convergence might actually vary, right? Because n actually depends on x. Now let's look at the definition of uniform convergence. So we'll say that the sequence converges to f uniformly if it's almost the same but not quite. So for all epsilon greater than 0, there exists a positive integer n such that for all little n bigger than n, and for all x in E, we have the same thing. We have the difference between f sub n of x and f of x, and that's less than epsilon. So the key difference here, mathematically, is that the n here only depends on epsilon, whereas the n here could possibly depend on x and epsilon. So intuitively, the word uniform is used because the sequence f sub n converges to f uniformly. In other words, at the same rate, right? Because the n only depends on epsilon, irregardless of x. X does not depend on x. So no matter what x is, it converges at the same speed. That's why we use the word uniformly. The rate is uniform. Before we stop the video, maybe I'll do a quick example, and we won't prove it. Maybe in the next video we'll prove it. Let's say we have the example from above, f sub n of x equals x to the n on 0, 1. So let's investigate the convergence of this sequence. So if x is 0, then we have f sub n of 0 equals 0 to the n, which is equal to 0. So it should converge to 0. If x is equal to 1, x is equal to 1, we have f sub n of 1, and that's equal to 1 to the n, which is 1, which converges to 1. And if x is not 0 and not 1, that means it must be strictly between 0 and 1. In this case, f sub n of x is simply x to the n. And it's pretty easy to prove that when x is a number between 0 and 1, as n approaches infinity, this will approach 0. So it looks like our f, the limit in this problem, is a piecewise function. And it looks like it's going to be 0 if x is less than 1 and greater than or equal to 0. And it's going to be 1 if x is equal to 1. So we could prove that this sequence of functions converges pointwise to this function. It turns out, though, that the convergence will not be uniform. And the reason is this. Uniform convergence preserves all kinds of things. Under the right conditions, uniform convergence will preserve continuity, differentiability, integrability. So if you have a sequence of continuous functions, like these guys, they should converge uniformly to a continuous function. So in this case, this function is not continuous, so the convergence of the sequence cannot be uniform. In the next video, maybe we'll prove this example. We'll prove that this sequence of functions converges to f pointwise. Thanks for watching, and thanks for visiting my channel. I hope this was helpful.